just like the rules of code, which is what we did yesterday, you can write a rule that changes numbers into other numbers. So for this example, this table represents the rule that we're going to add 1 to each number. So if I started with a 0, I added 1, it became 1. If I started with a 1, I put it into the machine, I add 1, it becomes 2. The input of 2 became 3, the input of 3 became 4. The equation that represents this rule is here, y equals x plus 1. No matter what number you input here, it gets put into what would be considered the function machine, or the equation, and you get a calculation. And you've actually worked with functions already. When we saw some of those visual patterns for the warm-up, you were identifying what the pattern was and what was happening each step. And even for some of them, we created an equation. Those were all functions. Okay. If I needed to plot these points on the graph, 0 and 1, 1 and 2, 2 and 3, and 3 and 4, that represents my line. So this is a function where the rule is to add 1 to each number. This is the information in your table, the equation that would represent this, and then you can graph it one of two ways. You can graph it from the equation, your y-intercept of 1, and then your slope of up 1 over 1, or you could have plotted points from the table. But the idea of a function is a rule, and that rule is the equation that we have. So let's take a look at this table. Our inputs are listed on the top. Our x values represent our inputs. We put in the number -4, and we got -7. We put in 3, and we got 7. We put in 5, we got 11. We put in 16, we got 33. We put in 25, we got 51. We put in 31, we got 63. What is the rule? What was happening? We put a number in. What happened to it to give us the output? So we're going to do the rule in words, and then we're going to write the equation that represents that rule. Take a look. Can you find the pattern? Can you figure out if this was the number put in, what happened to it to give you this number on the way out? What happened to that number when we put it in? What's our pattern? In words, what are we doing?
Doubling
Okay, so we're doubling our input,
and adding 1.
doubling the input,
Well, 1.
and then what? Doubling the input,
And then adding. Yeah, I wanted to say subtracting, but how was that subtracting?
so -4 times 2 is
Negative. Oh yeah,
-8, and then -8 plus 1?
-7.
-7. 3 times 2
6.
plus 1?
7.
5 times 2
10.
plus 1?
11.
Good. 16 times 2
32.
plus 1?
33.
And it works at 25 times 2 is 50 plus 1. 31 times 2 is 62 plus 1. Now the key is, some of you may look at this, who saw the -4 to the -7 and you were like, we subtracted 3? Okay, cool, that's fine, because you did here, right? But did you subtract 3 every single time? No, so we had to find something that worked for all of our numbers. And doubling the input and adding 1 worked for all of them. What would that equation be? Sarai. 2x plus 1. Absolutely. Okay. Now let's say I wanted to graph this, and I wanted to graph it not from the table. I wanted to use the equation. How would I use that equation? It's a great review from yesterday's quiz. How would I use the equation to graph the line? What 2 pieces of information do I need? Y-intercept and slope. Okay. How would I begin if I needed to graph that?
+1.
Where +1?
On the y.
On the y-axis, I'm going to find +1. This coordinate is 0, 1. And then what? I have my y-intercept, right? And the y-intercept, when your equation is in slope-intercept form, is here. For those of you that weren't able to find that, when your equation is in this format, that's where it is. That shows if I had an x of 0 and I substituted in if x is 0, y would have to be whatever this number is. That's why it's our y-intercept. Okay, so now I have my y-intercept. How am I going to use my slope to show another coordinate on my line? I can use my rise over run, which means what? Or how am I going to use that here? That is the slope. How would I represent that rise and that run here? Good, up 2 and over 1. Now what that means is for every additional x value, every time my input increases 1, I just slide over once, my total is going to increase by 2. Right? That's what that 2x represents. So this coordinate here would be 1, 3, and then I can go up 2 and over another 1 to 3, 5. And I can go up again to 4, 7. No wait, I'm lying. Up 2. Up 2 over 1, so 1, 2, 3, 4, 5. I was backwards.
It's 7.
I'm just gonna start over. Okay, 0, 1, up 2 over 1, x is 1, y is 3. Good, so 1, 2, 3. Okay, if I go up 2 and over 1,
2, 5.
2 and 5. And then up 2 and over 1 again, 3 and 7. And this is where I was trying to get to, even though I made a tiny mistake there. Because this value is actually in our table. The 3 and the 7 are there. The -4 and the -7 would be there. The 5 and the 11, they're all points on the line that represents this function. Y equals 2x plus 1. So a lot of times we have functions that are real scenarios. And that tends to be when most of us get that aha moment when we're working with a function, that we understand that each input is only one output. Okay? And this could be an example here. The table below, this table, shows the number of dog licenses issued in the town of Palmer over a 5-year period. So we're going to plot these points on the graph. How can I label my graph? What would our x-axis be?
Years.
The years. My input would be the years, and I can list these 1, 2, 3, 4, and 5. And my output represents what?
The number.
The licenses. How should we label our graph?
25.
We could do it by 25. Good. And the reason I like to ask that question is because when you do have to create your own graph, sometimes we forget that we need to make sure our graph is evenly spaced so that the graph truly represents the relationships that we're comparing and we have a really good visual. The whole point of graphing something is to get a visual of some type of data. And if our graph is not organized properly, that data may be skewed. So I can plug in some values. What ordered pairs do I have?
170.
Good, where I have the first year, 75.
2.
Second year, 100. Third, 125.
4. 150.
Okay.
No.
Yeah.
Wait.
What?
Oh.
What? Okay.
I didn't even see that till now.
Yeah.
So we have some stuff going on here.
I'm freaked out.
So what's the relationship between these input and output values? How is this changing from one year to the next?
That is not. That's good.
That's actually good. We're gonna get to that in just a
Every-
second. What's happening every year that passes?
Christmas.
What?
No, because we say like every year.
Oh, okay. I wasn't following there. What is happening every year that passes for these dog
Going up by
licenses?
25.
Is it always?
No.
No, what happens?
Till the 4th
Between the
year.
third
There-
and fourth year.
yeah.
So there's an issue in the 3rd and 4th year, but in these first 3 years it increases by 25, right? And then after, from year 4 to 5, it also increases by 25. Is this a function?
No.
Why not?
Because it's not, we have 2 numbers the same, and it's not a straight point.
It's not a function.
So
because-
let's get our vocabulary in order as well when we talk about this. So we have, we're saying it's not a function. Who believes not a function? Okay. Why is it not a function? Before you answer, look at the definition you wrote down yesterday for a function so that you can explain it with the terminology that we've been utilizing. Okay, Kate's got it. Explain to the class why this is not a function.
Well, like there's the input doesn't go out for one output, it goes out for two.
Which one? Which input? So Kate's saying that the input doesn't go out for one output, it goes out for two. What input gives us two outputs?
3 to 4. Wait.
Is the 125 an input or output?
Stop.
Oh,
She
this
tricked
happened
us.
This
This
happened
happened
yesterday.
yesterday.
Oh wait, so yeah,
It is a function.
It is a function.
Because each input still
FYI, I love that we're recording this right now. I love it. Why? Wait, so you were so convinced. You were so convinced that this was not a function because of why?
Because we done
Yeah,
the
Because you saw the 125 twice. But I think it might have been over here we caught that it was a function earlier. Why do we know that is a function?
Because there's because one input has one output.
Because each input, and in this scenario, it's not just the word input. Every year, how many values for dog licenses do we have?
5.
How many total values? So in year one, how many total values am I given for the number of dog licenses?
75.
Well, I'm given one value, right? For the first year, 75. For the second year, 100. For the third year,
125.
good. For the fourth year,
125.
right? And the fifth year.
150.
It's not like all of a sudden I said in year 6 we have 75 and 125. That would be a problem. That would not be a function. This is a function. Even though 2 of the years had the same amount of dog licenses, it still represents a function.
As long as we don't have the same input.
Now, what if I added in year 6 150 dog licenses and I added that? Is it a function now?
Yes.
Yes, still a function because each input still has only one output. Okay, so keep this situation in your mind. And now we're going to look at this. They think there's a relationship between the way that dogs age and the way humans age. For a long time, it was like 1 human year was equivalent to 7 dog years. There's actually more current research that says that that's not necessarily the case.
Really?
My dog here, Hercules, this little guy, he's so cute. He's 10.
Oh, he's
Right,
70.
so I know,
He's a
but
grandpa.
he might not be. I call him an old man. He's a little old man.
My
But he
dog
might not
is-
be 70 because I think my mom was telling me this because she got all excited that he's not necessarily 70. You'd have to look it up and don't quote me, but I think it was something like the first year is like 10 human years, but then the years after that are only 5 human years. We'd have to check it, and maybe I'll check it today just to bring it up tomorrow. But for now, this was the thought for a long time. 1 human year is 7 years. Could I put that on the graph?
Yeah.
What's my input?
Human years.
My human years are my input, and my output are the dog years. How would you want to break up the dog years?
By 7.
7's work.
Wait, hold up.
And how would I plot these points?
1 7.
1 and 7. So that's a line. What do you notice about this relationship? How's it changing from 1 year to the next?
Increasing by 7.
We're increasing by 7. Every 1 year for human life, we are increasing the dog's life by 7. That relationship, that 7, what part of the line does that represent? That increase of 7 is what for this line?
Slope.
It's the slope. That's the slope here. For every 1 year I'm advancing, I'm increasing 7. So I'm actually going over 1 and up 7. My rise over my run, my rise over run, my rise would be 7. My run would be 1. For every 1 year, I'm increasing 7 dog years. Could I write an equation for this?
Yeah.
What is the equation for this function?
Hold on. I'll do it. Y equals
Y equals 7x.
x plus 0.
You could put plus 0 because we know
7.
that. Why would it be plus 0? Why do
Because
we know that the y-intercept has to be at 0?
because he starts at nothing.
And not just that it starts at nothing. Add context here because we're not just talking about numbers, we're talking about something real.
Because for every 0 age in human years, there's 0 age.
Yeah, if I have 0 human years, then I wouldn't have any dog years, right? If someone's not born yet, I can't say that would be an age. So 0 and 0 would be a coordinate here, which means every time I increase my x value, I'm increasing my total y value by 7. Could I represent this as a function? Oh, I'm sorry, as an equation?
Yeah.
What? What would it be?
Where is it? Can you draw the line?
Could I write an equation that would represent that function? We already determined it is a function.
I don't know the slope.
Why? What's going on? If you were talking about your change in y over your change in x, we know we're increasing 1 year, so we're good. But then what's happening here? I'm increasing 25, 25,
0.
0. So the problem here is where?
There's an outlier.
That's an issue because my change. What is this rate? This rate is not what? It's not a constant rate, so I can't have one equation that would represent this function right now. I don't have. There's no pattern that continues through and that is consistent.
So I can't write an equation.
This is nonlinear. This is all over the place. Actually, we're gonna actually work on graphs like this in like 2 weeks. We're gonna talk about graphs that are not straight but that represent different situations.
Miss,
about the one that goes up, down, up, down.
Yes.
Miss,
Yes, we are. Yes.
why did you name him Hercules when he's so little?
His dad's name
I
was
was thinking
Zeus.
that.
What? He had a dad?
His dad's name was